Today we are diving headfirst into Kubernetes. For years now, it's been sold to the tech world as this ultimate magic bullet. It's the platform that promises to solve literally all your scaling problems, iron out those clunky deployment inefficiencies, and completely future proof your tech stack. But beneath that really shiny promise of an automated, self healing utopia, there is a hidden, highly expensive side to this technology that honestly rarely gets discussed. We're talking about massive engineering overhead, skyrocketing cloud bills, and a wildly steep learning curve that catches countless teams completely off guard. So, this brings us to a pretty massive paradox. Everyone tells you Kubernetes saves money by maximizing your server efficiency, right? Everyone says it scales automatically, making your infrastructure basically invisible. So, why on earth are so many companies spending significantly more money after adopting it? Why do solid engineering teams eventually just wave the white flag and retreat to simpler setups? And maybe most surprisingly, how are some organizations saving literally millions of dollars only after they leave it behind? Just imagine for a second your app suddenly goes viral, traffic spikes, users are just flooding in, and your traditional servers would normally start sweating, giving you that endless downtime anxiety. Now, imagine a system that automatically starts new containers, instantly replaces failed applications with zero human intervention, scales way up during those massive spikes, and then smoothly scales back down when everyone goes to sleep to save you cash. It's billed as the absolute future of infrastructure. And to be completely fair to the tech here, it actually does a lot of these things incredibly well. That is exactly why it's become the most popular container orchestration platform in the entire world. But the relentless industry hype often masks the pretty brutal reality of what it actually takes to get to that level of automation. To really understand the core problem, we got to look back at exactly where this tech came from. Back in the early 2000s, Google was operating one of the absolute largest computing setups on the planet. We're talking massive data centers scattered across the globe, processing unimaginable amounts of search queries every single second, and managing that kind of planetary scale manually. Yeah, that simply wasn't going to happen. So Google built these internal systems. First one was called Borg, and later on one called Omega. And these systems were absolute workhorses. They automatically handled deployment, scheduling, resource allocation, and recovery across literally millions of servers. Eventually, after years of proving successful inside Google, a lot of the core concepts behind Borg and Omega were bundled up, open sourced, and released to the public as Kubernetes. But here's the absolute crucial point. Google built these systems to solve Google's massive problems. And let's be totally real here. Most companies are not Google. Most companies do not operate 10,000 interconnected microservices across this massive global footprint. A typical business might have what? A handful of core applications, a moderately sized engineering team, and a pretty predictable user base. Yet, getting totally swept up in the hype, countless smaller organizations enthusiastically adopted the exact same heavyweight solution, custom designed for a global tech giant. They basically dragged all of that enterprise grade complexity into setups that simply didn't need it. A lot of folks assume it's the servers or the massive cloud bills that'll get you. But honestly, the biggest hidden cost is the human beings running the whole thing. When something goes sideways in this ecosystem, you need someone on your team who deeply understands container orchestration, complex software defined networking, persistent storage volume claims, security protocols, intricate monitoring, and just overall cluster management. That is a massive burden of specialized knowledge for a small team to carry. And the market rate for DevOps or site reliability engineers who truly get these systems, it's incredibly high. A small team might actually spend way more money hiring, training, and retaining the specialized talent than they ever saved through that promised infrastructure optimization. You know the old saying, deploying an application is usually the easy part. And it really is. Getting it running on day one feels like a massive victory. You run a simple command and boom, your containers are alive. But debugging a mysterious production issue, like say a stubborn crash loop backoff, or some ridiculously complex ingress misconfiguration deep in the networking stack at 2 in the morning, that is where things become brutally difficult. The expertise required to untangle a giant web of distributed microservices under the stress of an ongoing outage is highly specialized, incredibly stressful, and for sure very expensive to retain. And here's the part that catches so many teams completely off guard. You might be thinking, well, hey, we only have a tiny app, so our setup will be super simple. Actually, scratch that. It doesn't really work that way. Unfortunately, whether you run 10 containers or 10,000, the baseline complexity, what we call the control plane tags, remains practically the same. You still absolutely need the API server. You still need the whole monitoring stack to even figure out what's happening. You still need that complex networking layer configured, and you definitely still have to perform highly sensitive version upgrades. The sheer weight of the system just doesn't shrink down just because your business is small. So a massive selling point for adopting this tech is perfect efficiency, right? The scheduler tightly packs your workloads together like a giant game of Tetris. So you use your hardware as effectively as possible. But here's the kicker. Human psychology completely shatters this myth. The number 4x is incredibly common here. Why? Because, well, engineers are naturally cautious. Nobody wants their app crashing in production because it ran out of memory and triggered an alert that wakes them up in the middle of the night. So humans naturally request far more CPU and memory than their application actually uses. Sometimes they reserve 4 times more resources than needed, and the platform doesn't know any better. It blindly trusts the numbers we humans punch in. As a result, those highly expensive resources just sit there completely unused while the company pays top dollar. Ironically, it's not the platform creating the financial waste here, it's human psychology. And then, of course, we have autoscaling. We all kind of want to imagine autoscaling as this instant magical process where unlimited capacity just appears the exact second you need it. But reality operates under the physical limits of hardware. Imagine your website goes viral and traffic triples in a matter of minutes. First, the spike happens. Second, the system notices the strain and says, hey, we need more capacity. Third, your cloud provider starts physically creating new virtual machines. And fourth, those machines have to actually launch, initialize the operating system, download the container images, and finally join the cluster. Guys, this takes time, sometimes several minutes. And during that critical delay, users are already showing up. Requests are slowing down. Queues are growing. And traffic might even be dropping. The autoscaler is doing its job perfectly, but the physical capacity just hasn't arrived yet. Autoscaling is powerful, for sure, but it is strictly bound by the laws of physics. This expectations versus reality check also applies to the kind of work you're actually running. The platform is absolutely brilliant for stateless applications. We are talking things like APIs, web services, and microservices. If one of those instances crashes, another one just instantly pops up to replace it. And the user never even notices because it doesn't hold any critical data. But stateful databases, that is a significantly more dangerous story. Databases hold your customer data, and that data absolutely must survive server restarts. Storage volumes have to disconnect and reconnect flawlessly. Safe recovery is paramount, and a single mistake can literally corrupt everything. This is exactly why so many highly experienced organizations will happily run their web APIs in this environment, but fiercely protect their critical databases by keeping them on simpler managed database services. So, what does this all mean? Is Kubernetes just a bad piece of tech? Absolutely not. No way. It is a revolutionary platform that totally changed the industry. The real question you need to ask is whether it's the right strategic decision for your specific situation. If your organization operates hundreds of dynamic services distributed across global regions and you actually have a dedicated platform engineering team to manage the whole shebang, it delivers immense value. If you found this helpful, don't forget to like, subscribe, and drop a comment if you have any questions. Thanks for watching and see you in the next video.